Hello and welcome to this video for CSC A08 explaining mutability, aliasing, and cloning of lists. This code is just some week 6 example code. It can be found under the course website under week 6 mutation. Whoops. There we go. So at the beginning of the code we have two functions. They both change the first index of a non-empty list to the string x, capital X. The difference being is that the mutator changes the input list directly, like it changes the input list directly, and the cloner function makes a copy of the input list and makes changes to the copy and then returns the copy. All right, so let's just look through the code. Forward. So it just saves all the functions. So we have a list called myList. So alias list equals myList. This is what we call aliasing. It's a different variable. It's different from myList, but it refers to the same list as seen here. Now this clone list, this is called cloning, where we take a list and we copy it. It doesn't refer to the same one. Clone list will not refer to the same one. As seen here, it refers to a different list. So at first they all of these seem to be the same. But we can see in the memory model already that myList and alias list are the same list, while clone list refers to a different list. It just so happens to be that they look exactly the same. So we're printing all of them. No surprise there. But what happens if we change the original list? So myList 0 equals 99. So we're going to change 0 over here to index 0 over here to 99 instead of 1. So we do that, but we see that myList and alias list both point to the same list. So if you print them out, you can see that both myList and alias list have that change, but since clone list is a different list, that change isn't seen there. But be careful, cloning only makes a shallow copy. This can be shown as, so first we're going to just change all the lists to myList equals that, alias list refers to the same one, and then clone list refers to myList. So it just copies whatever is over here, but since it's only a shallow copy, if you ever have a list within the list, both the copy and the original will refer to the same list. So if you did something like this, where myList 1, 1, which refers to this list, index 1, equals 99, you can see that although myList and alias list point to the same one and clone list points to a different list, all three of their index 1s point to the same list. So if you print all of them, the change can be seen through all three of them. So another example, oops. X equals 1, 2, 3, that's just the basic list, and then Y equals whatever mutator X returns. So we'll just see that. So you'll notice in mutator that in the function mutator that it does not have a return statement. So Y is obviously going to be none, but we're going to still see what mutator does. So it changes the input list 0 to X. So it's going to do that, as seen there, and there's no return statement, so the return value is none. There you go. So X is this changed list, and Y is none. So if you print both of them, you get the changed list and none. So let's do that again, except use cloner. So Y equals cloner X, and we can see here it makes another list, clone list equals input list, and you can see here it copies it. There you go. So it refers to a different list. And it makes the same changes to the clone list instead. There you go. And it returns the clone list. So x is still equal to the unchanged original list, while y is the copy that has all the changes on it. So if you print both of them, you can see the original list, and then all the changes are made to that. So now I'm just gonna edit the code a little bit to do the advanced tracing version. Oops. All right. So we initialize the two functions again, and now we do the advanced version. So x equals a simple example of a list within a list again, and y equals mutator x. So we'll see what it does. So it changes. So mutator again changes changes the first index, which is another list, and within that list, it changes the first index of that list to x. So this one will be replaced with an x. And since there is no return statement, then the return value is 0. So if you print x and y, x would be this list that we had before, and y is just none. So we do that again. So we just initialize the same list as we did before. And then we do y equals cloner x. So it takes the input list, makes a copy, a shallow copy of the list, and then it changes the first index, which is a list, and then the first index of that list, and we changes it to x. You noticed that, you should probably notice that it was a shallow copy, so in the end it changed both lists. So it returns clone list. So currently x and y refer to different lists, but because within there were only when you do something like this, it was only a shallow copy, and you change the list and you print both of them look exactly the same now, as it was only a shallow copy and there was a list within a list, and you were changing that list within the list, and they're referring to the same one. So you can see that it's exactly the same, even though they refer to different lists. And that it was an example of mutability, aliasing, and cloning of lists, as well as their visualizations in the memory model.